Hi there. In my last video, I went over putting the CL in for slides 1 and 2, and this video is going to cover the CL for slides 3 and 4, which are a bit more difficult than the last two. So I just want to really quickly show you what the CL looks like for these other ones. This one was a multiple choice, so it had check equals this is selected, option 2, so the second thing down on the list was the one that was correct, and then we write correct check. And that will give you on the dashboard an X if it's the wrong answer and a check if it's the correct answer. Again, that correct check and the wrong X only show up on the teacher side of things. This is not something that will show up for students, not even in this window. That only shows up on the preview. Same idea here on this one. It was a math input, and we made it so that it had to be only the answer of 13 that it will accept, and not something equivalent to that, depending on what you want. So here we have check, and at first we didn't have this piece in there. We had, we also didn't have it and, there we go. We had this numeric value equals 13 and stop there. So it was accepting like 26 over 2, and it was accepting, what is the actual problem? It was accepting 2 times 5 plus 3, and it was saying that that was correct. And probably you want the students to evaluate it and not just type in the substitution. So if you want your question criteria to be very specific, then you can also make your answer criteria very specific. So by entering in the count number usage of 13 showing up once in the problem, in the response, then it makes it very specific, like this is exactly what we need to see. So let's move on to the third one here, which is a bit more difficult. So here students are typing in fractions. So 5/16 multiplied by 2 is 10/16, and then adding on the 1/16 will give us an answer of 11 over 16. So we want over here 11 over 16. Right now, it doesn't have any CL, so it's giving us the dot. As a reminder, the dot on the teacher dashboard says, hey teacher, you should look at this slide. The student did something. The student interacted with this slide is all that it says. Nothing about if it's correct or not. So let's change that and make it so that it shows up as correct or not. So I like to type in, for anything that's not just like a numeric whole number, I like to type it in this input box, and then I highlight it and I do Control-C to copy it. And then that way when I come to the CL over here, I can type that in easily just by pasting it in. We are going to do check like we did on the other ones, but before we do, we have to do something a little bit different because it's a fraction. So we're going to say this fraction is a numeric value, and we're going to name it key, as in answer key. I'm going to use this little tick mark that's below the tilde symbol on one of the keys on my keyboard near the number 1. And I'm going to paste in that fraction. Notice that the fraction's going in like this rather than as 11/16. And that's because, again, with coding, it's all very specific. And that, that thing that I pasted in is the LaTeX way of writing it. And I'm not positive that I'm saying that correctly. All right, so what do we want to check? We want to check that this component, so again, this, and we want to check that its numeric value is equal to the key, that it's correct. And if it passes that, then we probably want to say that it's correct, right? So let's take a look at what it accepts and what it doesn't. We're going to hit done and preview. And let's say a half. Okay, so definitely marking a half as wrong, which is great. 11 over 16. Notice that it's giving us that dot. That dot is saying, teacher, you need to check this. But didn't we just write in the CL that is supposed to check it for us? Well, we certainly did, but something's happening that happens to a lot of people, including myself, when I first started learning this. And that is that I did not realize when I first started doing this that if you have multiple components on the screen, then the computer is going to be checking each and every one of those for correctness. And if you leave any of them out of it, then it doesn't know if the whole thing is correct. And it's always answering with a check if it's the whole thing is correct. So the note component, we don't have to worry about correctness for. The math input, we definitely want to worry about correctness for, and we put that in already. And our other component is the sketch component. So actually it is looking here and saying, ooh, what am I supposed to mark correct? Did they put down the correct thing? I have no idea. So what you can do is say read only true. And that means, computer, forget about this component. Just say that it's true, that it's correct, and look elsewhere and see if that other stuff is. So now if we go back here and we try a half again, we get the incorrect. 11/16, it's correct. So things look good. But in this particular example, I went a little bit further and I said, please enter your answer as a fraction that is fully reduced. So it has to be a fraction that the students answer and not, say, 22/32, which it's marking correct and that is not reduced. Also 0.6875, 0.6875. That's great, it's equivalent, but that's not a fully reduced fraction. That is a decimal and it is marking it as correct. So if your directions are very specific and you want it to stay very specific, then you need to add a little bit more code to make sure that it corresponds in the CL. Going back to the CL, in our check, let's say a little bit more about that. And we want to count the number usage, just like we did in one of the other ones, the last video of this LaTeX. And what number do we want to look for in that answer box that the student writes? The student should be writing 11/16. They need both those numbers. 11 should happen once, and count number usage for this LaTeX. The number 16 should also happen once. So now if we go back to the student preview, half, still wrong, good. 11/16, correct, good. 22/32, incorrect. 0.6875, incorrect. So notice that it's limiting even further what it will accept. Really, the only answer that it will accept is 11/16. So you might, you can do it another way, but it's not as precise. And that's by comparing LaTeX, which I'm not going to go over. So let's go on to slide 4. Slide 4, the answer here is 25√3. And so I'll write 25 square root of 3. I'll highlight it, Control-C to copy it. Right now, no CL, so I'm getting the dot on the dashboard. And remember that because I have a sketch component here, I really need to put some CL there as well. And I don't really care what the student does, so I'm going to say read only true. And it's really just for the student's benefit. But over here, I want the key to have a numeric answer of that. I also want to, in this one, I want to compare the two answers, what this says, which is the answer key, and what the student says. So I'm going to say input is going to be this numeric value. That means key is, this is the answer key. Input, this is what the student types in. And so now I want to do something with those. And this is where this particular one gets a little, well, a lot difficult. So I'm going to go through it a little bit fast. I'm going to call a function f, and it's going to be a simple function, which is something that Desmos uses. And just for the ease of typing it, I want to take the absolute value, the absolute value of x minus y. Copying that and bringing it back here is a helpful trick for myself and probably for you. And I want to have both x and y in that simple function. So that simple function takes something and subtracts something else. So what do I want to subtract? I want to do what I know the answer key should be minus what the student puts in. And if they've done it correctly, it should equal 0. So I'm going to call that the difference. The difference of f, and we're going to evaluate it at both the key and the input. And tolerance, you can set at anything really that is fine for you, but I'm going to set it at 0 so that it has to be 0. And the check, we don't need this because I've already done that. We need the difference to equal the tolerance. So if we subtract them and they're exactly the same, then we're going to get 0, and that's what I want it to equal. We'll stop there for now and say that the correct is the check. So let's check that out. 25 square root of 3, and it does check out. And if I make it something like 5 root 3, it makes it wrong. But just like before, if I enter in, I did put a tolerance check of 0. Let's say that I had a tolerance check that was a little bit more forgiving. Then I might also want to add in count number usage. For this LaTeX should have the number 25 in the student response, and it should also have 3 once in the student response. So you could put that in if you had a slightly bigger tolerance. I don't really need it because the tolerance is 0. So that will work. Again, showed this before, but you'll get the check on the student dashboard. Whether they use or don't use the sketchpad doesn't matter because it's always true. So I hope that helps your CL game, and I'll be back with more videos later on. Bye.